Okay, hello class. This is our last lesson in Java. Remember that all code in Java must be inside of a class. So today we're going to talk about how we make a Java class. Now, we're going to start off by just kind of reminding ourselves the components in a Python class. This was the last thing we learned in Python actually too. So we start off by defining a class, and we have a constructor with underscore init. We have a couple parameters going into that constructor, and we always had to use this word self as the first parameter of any method or constructor. Then we had these attributes of the person, anything that is self dot whatever. So self dot name, name is a attribute of the person, age is an attribute of the person. And then we also learned how to define methods of that particular class, and we can have the method do whatever we want. And then once we've defined the class, we're able to then use it and create our own people, our own person, Steve, age 9, and then we could have that person do things through the method calls down below. How do we now do the same thing in Java? Now you'll notice that actually there's a lot of similarities. Kind of at a top level, the concepts are all the same. The whole concept of defining a class, defining attributes, defining methods, and then once you have those things defined, you make the objects and then you manipulate the objects through use of methods. Now, the first line is exactly the same. Then we define our attributes. Now, notice something interesting about our attributes here. In Java, the attributes are outside the constructor. And that's different than in Python. In Python, the attributes that we made, we could make them wherever we want. We would typically create them inside of the constructor. We could have put them down below as well. I could have created a brand new attribute within greetings if I wanted to. But in Java, all of our attributes are defined, I'll say, within the class but outside of any of the methods. And typically, it's good convention to put it right underneath the class person right here, to start off by defining any sort of attributes, any sort of data that person contains. Now, the other thing is we declare it to be private. So in Python, everything is public. There is no such thing as private versus public, but in Java there is. And so it is good practice to define all of our attributes, fields, attributes, to be private. And that means that there's no way to access it from the object itself. What I mean by that is, over here in Python, we created this object, this person object called P1. And if I wanted to, I could actually do the following. I could say P1 name equals some new name like Joe. And that's completely legal in Python to do this. I can access the name, I can access p1.age, I could read it, I can change it. But in Java, if I called them to be private, these attributes, then actually doing this is illegal. I cannot do p1.name, p1.age. So that's what it means to be private, and it's always good practice to make them private. That's just kind of the philosophy of object-oriented programming, to create your attributes to be hidden inside of the object, and the only way to interact with the object is through methods. To read attributes, to change attributes, you always use methods to do that. Okay, so that's attributes. Let's look at our constructor. In Python, it was underscore init. In Java, notice that the name is actually not underscore init. It's actually the same thing it's the same name as the class itself. And so, in fact, it's also the same name as the file name. So you have person.java, which has class.person or class person, and this is the constructor here, public person. So we make the constructor public. We have our two parameters here. These are the two parameters N and A here. Notice we don't need self. So that's actually maybe something that's interesting right away. What is not needed is this whole word self all over the place. You don't see it for greetings. You don't see it for the constructor. Just not needed. Now, if you remember, we said that all methods need to have this adjective in front of it which specifies what it returns. And the constructor here, you notice, does not return anything. So you might think, oh, okay, that means I need to have this word void here. But actually, no, you're not. Actually, this is actually important. All you want is public person. You do not want the void. That will actually kind of mess things up. So this is our constructor, and we can use that to initialize our attributes here. Okay. Now, I do want to make a little side comment here. You know, in Python, we could do the following. I could name. Let's actually do this one. I could name this attribute or this input parameter age, and then over here I would then change this to age as well, and then I could initialize self.age to be equal to this input parameter age, and that's fine because there is no, confusion here. Self.age is a different variable. It's a different it's a different variable than the age variable here. The age variable is my input. The self.age is a attribute of this person. Now, if I did that over here on the Java side, let's do that. So I'll make this age, and I'll make this age as well. Now this is weird. This won't work. In this case, look, I have age is equal to age, and in this case, age is this input parameter. This age is also the input parameter, and this is kind of a silly statement now. Age is equal to age. We wouldn't really want to do that. In this case, this age here is this local input parameter, and it is not this attribute over here. And so how then would I initialize this attribute if age is the name of my input parameter? Well, the way we do that is that we, kind of similar to the self.age, there is a variable that is just like the self, and it is the word this. This is really the same as self. So this dot age now references this attribute up here, age, whereas this variable here is this local parameter here. And notice that we didn't have to pass this as the first parameter here like we had to over here. This is just a magical variable that exists that allows us to access these attributes either by using this dot age or by just saying name itself. In that case, there is no confusion, and you don't really need to have this dot name in front of it to reference this attribute here. Anyways, this is just kind of an aside. It's not really necessary for you to know that. But that's why in this case over here, I used A instead of age. Okay. Now let's look at a method. I have my greetings method over here on the left, and to do it in Java, I just say it's a public method called greetings, and it is a void method in the sense that it does not return anything. Notice there is no return statement, so I need to then specify it being a void method. Okay? Then the last thing, this is the completion of my Python class, and this is the translation of it over in Java. Now over here is where I'm actually going to use it, and what I'm going to demonstrate here is how I'm going to use it within a static void main method here. And in a sense, this is kind of outside of the class description here. I could have even put this main inside of a whole different file, but I didn't want to just because of convenience sake. But you can consider this public static void main method right here to be a separate piece of code, just like this is a separate piece of code to the class recipe up on top. So down below, I'm going to make my person. I'm going to say P1 is equal to new person here. And this is really the only kind of special thing that's a little different than Python. And we've seen this already before, so actually this really isn't a new thing. And then once we have this P1 object, I can call methods P1.greetings just like we have in Python. Okay, so to summarize a bit, to summarize all that we talked about just now, the Java constructor, instead of being underscore init, it is now the name of the class itself. So in the previous case, person was the class name, person is the name of the constructor. And the constructor never returns anything, and in fact, you should not define it to be a void method either. You don't want to put it there. Self is not needed as the first parameter of every single method or constructor. That's very nice, very convenient. I kind of like that syntax feature of Java. And attributes, class variables, are just defined outside of the constructor. And in Python, it was self.attribute name, but now you just define this attribute name as a variable kind of at the top level of your class, you could say. And generally, we follow good object-oriented kind of philosophies, and we make all of those attributes private, so they're not allowed to be touched or modified or even kind of read unless you're doing it through the use of a method. Okay, so that is that's Java classes, and what I want you to do right now is to practice, take this Python bank account class and convert all of this into a little piece of Java code, just like I showed in the previous example. I'm going to pause this video for a few seconds, and then I'll go to the next page. 1, 2, 3. Here we go. So this is the answer. I'm going to highlight some of the things I just want you to make sure that you kind of followed. We need to make it private. These attributes here. The attributes are outside of the constructor. And I did have to decide upon the data types. Now, certainly owner is a string, but I did have a choice for the balance. And, you could have done an int, but you could easily have made it a double. And in fact, maybe a double would be better because money has, it's not just even dollar amounts. You could have some cents. So maybe a double would be better. And in that case, I would have made all these other declarations here double as well. We have our constructor. You notice that the name is the same. We have our methods here, and I do want to highlight that don't forget to put void here, because in this particular method deposit, there is no return statement. Now, in this case here, withdraw does have a return statement. It returns the balance. The balance is an int, so I then say withdraw is of type int. Okay, and then at the very bottom, don't forget the new. And we're putting this, just for this example, we're going to put this code inside of the main function right here, which again, in a sense, is outside of the class. It's a separate piece of code. It's not this piece of code that kind of belongs in every single object in a sense. Okay, so that's the lesson today. I will be signing off. Okay, bye.